Would it be cool if we can build a robot that is not as big as this one, but it can be smart enough to avoid obstacles when it moves, and do other cool stuffs? That is exactly what I am doing in the summer of 2013. Hello everyone, my name is Wenran Chen, and I am a senior mechanical engineering student from the University of Michigan. Thanks to the program Summer Undergraduate Research in Engineering, or SURE, I joined Professor King Oldham's project, which is focusing on building and testing a 10mm long microelectromechanical robot. This is a concept drawing of our robot, and my project is mainly about testing and finding the characteristic response of the tactile sensor right in front of the robot. The tactile sensor, as well as the whole robot, is made of a material called PZT, and it has an interesting effect, piezoelectric. That's to say, the material will produce an electric charge when it is compressed or expanded. Conversely, a mechanical deformation is produced when an electric field is applied. Well, how does the sensor work? Basically, it will sweep through space, and when it hits an obstacle, the resonance frequency of the sensor will change. This is a model that I made in ANSYS. It simulates the motion of the antenna-like sensor when an electric field is applied. As the animation shows, the tip of the sensor is sweeping back and forth to detect potential obstacles. I can also have the resonance frequency under the ideal conditions. In real world, because the motion of the sensor is so small that it cannot be caught by naked eyes, I used a microscope with the high-speed camera attached to record the motion of the sensor. This video was recorded by the high-speed camera, and it shows how the real sensor works when a current passes through. In addition to the high-speed camera, I also used a device called LDV, stands for Laser Doppler Barometer. The LDV can generate a laser beam on the surface of the sensor, and by comparing the reflected laser beam, you will make measurements of the vibration from the sensor. I also built a sensing circuit which can eliminate environmental noise, mostly 60 Hz, and also amplify the signal generated by the sensor. At last, I wanna thank Professor Oldham for giving me this opportunity to learn so much from him. He's always super helpful and knowledgeable about every question I asked. Also, I wanna thank Zhongshu and his help in fabrication of prototype tactile sensors, and Daniel, Junhong, and Catherine for helping me setting up the equipment in the lab. Without them, this summer research experience won't be this meaningful. Thanks for watching my video, and I am Wenran Chen.